Get my recording going. All right. Once again, my name's Mike. Like I said just a second ago, for those of you that were in here, we are going to end a little early today. I have some online training I have to cover after lunchtime. I was out on vacation last week, so some things got added to the calendar that I wasn't planning on, and I'm the only trainer here today. So first thing I want to show you guys, just so everyone knows where it's at and where to find it, is the pre-recorded ones of these, the ones we've already done, because we've done a few of these. So all you have to do is go to BobCAD-support.com. It's a website. You guys may have been on this before. It's a new website. We just rebuilt the whole thing within the last month. It just went live. You do not have to have a sign-in for this. If you have one, it will show up the content that you have on your account. So if you go up to training, excuse me, and you go down here to say Training Professor Series, if you have training videos on your account, they will automatically open up in here under the owned Training Professor videos. So you will have to have a sign-in for that. Easiest way to do that is actually just contact tech support, and they can make you a sign-in very quick, very easy. That way it's all set up properly. We can double check everything. The thing I really want to point out to you, though, right now is I'm not signed in as anything. That's why I don't have any of the owned training videos up here. But if we go up to the training tab and right down here to the recorded virtual events, this is all these recorded virtual events that we've done. So we have a bunch for mill, and for today we're going over wire EDM. So we actually have 4 wire EDMs that are already done. And it wouldn't be a bad idea to kind of watch all of them. Me, Andrew, and Darren were the trainers here. We all kind of have different things that we talk about during this. Andrew definitely gets into more of the settings. So if you are looking for doing settings and stuff, I'm not going to go too crazy with him today. I might bring him up a little bit. But right here, his event will cover a bit more with that. And then for myself, the one that's already pre-recorded on there is probably more just tool pathing, getting used to creating tool path with your wire, different, 2-axis, 4-axis cuts. So just be aware, that's what they're at. Right now they're in version 33. I'll be working inside of version 34 today, but the steps that you use for wire EDM have not changed in either version. So whatever you guys see in those videos, if you do have version 34, it will translate directly into what we're doing in version 34. But with version 34, you also get the benefits of having the, a couple little shortcuts. Really not for wire EDM. There's really not too much of a difference, honestly. So just going to get started and look at some 2-axis open cuts. I seem to do a lot of 2-axis inside, and we're going to do some of that as well. We're going to look at some coreless cuts and everything. But I was looking at a few parts that someone made on GrabCAD, and I kind of like the way they were linking everything together. And it essentially turned all their closed shapes into open shapes. So with this part that we see on the screen right now, I added just this little, it's a 16th inch wide or a 16th inch wide little gap, and we're going to feed in. And then depending on if we choose, if it's a punch or a die, we're going to be either on the inside or the outside of that as we go and machine this. So it kind of depends on what we want. There's many other ways to do this as well. You could drill a hole in the part and then feed from the hole, which is what we'll look at when we do some of this coreless stuff right here. But for now, here is our a gear, just a simple gear. So I'm going to pull up the cheat sheet. I always like to show this off just so you guys know that it's available or where it is. And so we're just going to open up the help system. So file. And then I'm just going to go down to help here. And then I do have the use online help turned on. So it is going to load in and retrieve the newest help system that we have available. And then I'm just going to go right here to the BobCAD-CAM help. I believe if you uncheck this and go to BobCAD-CAM help, it will give you the same list. But I always use the online one so I know exactly where it's at. So when this loads up, it's always going to load to the exact same page. All right. And this is important because if we take the same steps, it's always going to be in the same spot. So it always opens up to this introduction page here. And so I'm going to go right down to the bottom where it says using CAM, and I'm just going to click on that one. Now, when this first loads up, we're going to see this option here called the Read Me First CAM Quick Guide. Now, this quick guide is a very generic process. It's not specifically for wire EDM, so there will actually be steps that you probably take out of this. But it's really just the generic steps of doing any bit of tool pathing inside of BobCAD. Whether it's for the wire EDM, whether it's for a mill or a lathe, or even getting into mill turn, and well, everything else is all mill. So the general process is after you have your geometry created, and whether you drew that here in BobCAD or you imported a model from somewhere else, this is the general process. So you can start by creating a new CAM job. And that's just telling BobCAD that you're starting a job, whether it be mill turn, wire EDM, milling, whatever it is. The second one is selecting a workpiece. And I just want to say workpieces, and you can actually click on this. You see any of these blue links, you can click on them. A workpiece is a solid model that represents your final finished part. And with wire EDM, it's kind of 50-50 for me. I do get a lot of solid models, but I probably get just as many just wireframe part files. So what we see right here on this little gear that I created, this is the same as having a solid model that represents all of this. And a lot of times with wire EDM, if I have a solid model, one of the steps I take is actually extracting the edges off of it to get just the wireframe, because I can't use surfaces for wire EDM, so there's really no point. I'm really just using edges, and if it's a 2-axis, I could do an edge with a taper. If it's 4-axis, I need the top and the bottom edges of the part, and I'll pull up a quick example of that and go through a little 4-axis near the end here. So again, with that cheat sheet up, the first step we'll see is start a new CAM job. Well, if you forget how to start a new CAM job, that's why this is so great. You can go in here and just click on that button. And in here, it'll tell you how to get to that CAM job. So in the CAM tree, you could do it like you've always done it by right-clicking on CAM defaults, going to new job, or there's a little shortcut button that lets you start a new job, or another shortcut button. There's actually 2 shortcuts to start a new job. The first one, again, is if we go to our CAM tree, if we right-click on CAM defaults, that top option there that says new job. The other option, one of the shortcuts, is right here just under where it says CAM tree. There's a new machining job to the CAM tree. And then the last one is up here under CAM, you have new job. So it doesn't matter which one you click, you just pick one. And that's now going to create the milling job, or the job. We haven't picked our job yet. And so we'll see we have milling, turning, mill turn, wire EDM. This is all dependent on what's on your license. If you guys don't own a milling machine, or you don't use your milling machine with BobCAD or your turn or your mill turn, you won't have these options, and it'll automatically default to the wire EDM for you. So we're just going to go down to wire EDM. Now, if you've gone through this before, or really if you've installed a post for this, a lot of times when you install the post, the way the posting department sets it up now is when you run the exe for the post, not only does it put the post in the correct folder for you, it also sets the default machine. So if you've gotten a post made, it should automatically set up as the default machine for you. And so I'm just going to use the Sodic Mark 21, and then I'm going to hit OK. Now, if it didn't pick the correct machine for you, what we're going to want to do is go to the CAM defaults right here. So you can right click on CAM defaults, and then we're just going to go right down here to current settings. Now, inside of current settings, when it loads up, give it a second, there we go. The first thing we'd want to do is pick the wire EDM that we want to use. So again, this time I'll pick my Sodic Mark 25. Now, if that's the machine I want to use, and that's the machine I want to pull up every single time I start a new job, then what we can do is say save as a default. And all you do is set the machine, save it as a default, and really you want to make sure all your settings are right, because it is going to become your new default machine. So if your 4-axis output isn't using 4-axis entities, it's using X, Y, U, V, then you're going to just want to make sure to turn that on. Now, that setting should, if you bring in a machine, or really you bring in a post, that option should be set up from when the posting department worked on everything, because they're the ones doing kind of the initial virtual machine build of this, post processor. But a lot of wire EDMs are automatically built into the system, and you might not need changes, or you might need just minor changes. So sometimes the default machine, if they're just going to make a modification to the post, they might just make the modification and send you the new post without doing the whole executable file, which does set up the defaults. So just be aware that save as a default button after you pick the correct make of your machine will automatically set it up so it gets picked every single time. Now, over here for the machine definition, you really don't have to worry about anything on this tab. This is the virtual machine build that gets handled inside of BobCAD, and most of this stuff's already done, so it's not something we need to worry about. The EDM setup right here, this is where you can set up your maximum taper angles, your maximum tapers with your lands, and then some machines do use an upper and lower guide location, and so these are the locations usually above and below the part that those guides are going to be floating around at. If your machine doesn't use the upper lower guide location, then this is just irrelevant. Now the taper display extend, this is a setting specifically for when you're doing land and taper cuts inside of BobCAD. So the land and taper, you have a flat and the taper on your walls. So you have a flat wall and then a taper down. And so this is just how do we display what that looks like? Do we show you the full lines for both the straight cut and the taper? Or do we just show you kind of a straight cut and a taper? I'll show you the difference because this is a setting we can change while we go through our parts. All right, so this is not something you're locked into, but you kind of are. And then your auto threader, and then whether or not you have us outputting a start hole program, depending on if you got a whole machine or how you're getting those holes in there. Right here for the EDM posting, we have our post processor. So you'll see this one grab the Mark 25 post, and it might be the only post I have in here. Let's see, do I have a 21? Yeah, I do. So it did have a Mark 21, so I must have set that up at some point with the wrong post processor. Totally happens. The whole post, again, if you do have a whole machine, you can talk to the posting department and they can get you a post for your whole machine. And then we have our NC file path. So this is the location that we're going to save a copy of the NC code. And then right here, we have the actual file extension that your machine needs. So be it .nc, .txt, .tap, whatever your machine needs is what you're going to want to enter here, because then when you go to save the code later on, it automatically saves as the correct file type for your machine. Right here, we just have our choice of whether the post outputs in G code or ISO command code. That's really just dependent on the machine. If you do have a command or ISO code, you definitely want to get in touch with the posting department and talk with them about making sure everything's set up properly. Then you have your default program number. This is just the number that's going to get added to the beginning of the program for every program as you go through it. Your sequence number that you're starting with, your increment for your sequence number. So if we say start at 1, then the next line is going to be 2, 3, 4, and so on. If you said start at 10 and then increment by 10, your lines would be, N10, N20, N30, and so on. Sub-programs, if you have them, if your post is set up for them, you can use sub-programs, but it's not something I usually recommend because BobCAD doesn't really treat sub-programs as the same shape. So even if you have two pockets that are the exact same size and everything, instead of just defining the two locations for that same pocket, you would define a location for the pocket and then a second location for technically the same pocket, but a different pocket. So it doesn't really benefit me too much. Totally up to you guys, though. You will have to make sure that that opens up properly. You will have to work with the posting department to make sure that's working properly, though. We have output cutting conditions. So that's just really dependent on the machine. And if you have a database built in with it, you can output your cuts to separate files. And you can tell it to output the guide positions. The automatic comments that are inside the code are just the parenthesed out comments that we add into the code all over the place. These are things that are going to have their notes for you inside the job. We'll see some at some point. And then output file breaks, just breaks in the file depending on how your machine needs to accept this code. Not something I usually run into or that I've ever run into with anyone that I've worked with, but it's in there because someone needed it at some point. So maybe you guys are one of those guys. So after you have everything all set up, go ahead and hit OK. And what we'll see here is if I expand this Mark 21, you'll see it has my Mark 21 post. So that's kind of the first thing we want to double check on. Make sure we have the right post processor. With wire EDM, it's not a big deal. If you do have to change your post halfway through a job, just like milling and turning, it's really not a big deal. The only one you really got to worry about that with is mill turn, because different posts, different machines, all that kind of stuff. So again, right here we have our workpiece. And normally the workpiece is something we can get through when we start our job. So normally I'd go to wire EDM and I'd go right to stock wizard instead of hitting OK. And then this will take me to that workpiece page where I'm supposed to pick a solid model, which I don't have right now, so no big deal. And then I just bypass it. So for us, we're going to go right into the stock wizard. So if I expand stock here, or yeah, I expanded it, below it we can see our material. And I'm going to start by just right-clicking on stock and going to stock wizard. Now, the stock wizard, if you guys have used the system in any other capacity with any other features, like if you have a mill, this is the exact same stock wizard as the mill. So we have rectangular stock, we have cylindrical stock, we have wireframe stock, which actually allows me to choose a piece of wireframe geometry and actually calculate the stock out. So that's kind of one of the two options we're going to get when we cut this part. We have a solid model and an STL, which needs us to either have a solid model, which we don't have, or an STL that you've saved that represents what the stock is going to look like. And then the final option is a revolve stock type, where we're able to take a chain of geometry and revolve it around a specific axis. In our case, not going to mess with anything there. So I'm just going to go with this part. I'll go with rectangular stock. I'm going to say the geometry from the graphics area. So it's looking at the largest extents of the part, especially since we only have wireframe. It's just looking at the largest bits of the wireframe and going to create a piece of stock from there. If you did have any lines or anything hanging out, floating out in space, it could give you some odd results. So definitely make sure you got your stock drawn. And you'll see over here, I actually made a layer specifically for the stock so that I could draw that rectangle around that gear and get it all set up to the right size. So I'll just say calculate my stock, and we'll see it's 5 by 5. And then for the Z, it's currently just set to 1 inch thick. This is all just going to depend on what you need. So I'll go to 2 inches thick right there. And there we have it. All right, just like that. So down below that, your stock orientation is something you shouldn't usually have to mess around with. This is usually only going to be used if when you import your part file, it opens up on an odd angle. You know, if it opens up just floating out in space somewhere, instead of trying to get that part to lay flat and sit in a nice, clean area, which actually isn't that hard anymore with the new align feature, but instead of having to fix the part to make it sit right, you can orient your stock to match your part. This is super common when you get part files that come off of assemblies, because a lot of times when we import the part off of an assembly, the origin of the assembly is what's used. So that's, we're going to put the assembly origin on XYZ0 here, but anywhere where the part is attached to the rest of the assembly, that's how it's going to open up. So you might have parts floating out in space and, a little bit more difficult to work on. But in this case, since all of our geometry is just flat right there on the XY plane, we do not have to change anything with that stock orientation. And then finally, we get to the actual machine setup page. So this is where we're setting up our machine setup, our work offset, our G54, E1, whatever you want to call it. This is where we're zeroing everything out from. And so for me, I'm going to go ahead and pick, let's think here. I could go with the middle of the stock, or I can go with the middle of the chain I'm about to do. I'm going to go with a corner, and I'm going to pick this corner right up here. It's pretty close to my start point, so I could do some math to figure out, reading through the code, I will be able to figure out where this start point is right over here, so that's not too bad. So I'll just leave it right there in the corner. But again, you can pick wherever you need, wherever you're going to be zeroing out from. Some machines, you'll have to pick the bottom point on the stock. You'll have to pick a point down here, and then you're going to define kind of the height upwards. But I'm going to go from the top down right there. And then right here, we have our work offset. Now, work offset number 1 is going to be the equivalent of my G54 E1. It's the first work offset that your machine is going to use. 2 would be G55. 3 would be G56, and so on. It's for as many as you need. And I believe this value is actually defined in the wizards, the settings page. So we could set up as many work offsets as needed. They might also be run through the post. So if you need more, looks like I have 26 on this post. If I need more, I could talk to the posting department and they will be able to add more work offsets to the job for me. So I'll just leave it right there on 1, and then I'm not going to do any shifting for my work offset because there is no virtual machine as part of the wire EDM. All we're really going to see is the guides and the wire itself. So when we're done, we can hit OK, and now we have our stock created right there, and we'll just go ahead and blank that guy out, and that's it. Now, right below that, we have tool steel set up as our material, and if we right-click on this, we can go to Edit. And this is where we could choose the material as well as the wire diameter. So I'm going to go with tool steel, and I'll just use this 10 thou wire here and then just hit OK. Now, if you need more than that, that's all going to rely on having a cutting conditions database. And some of you guys might be able to see this. Some of you guys, depending on what machine you have selected, you will not be able to see it. But right here, you have this edit cutting conditions page. And when we open this up, this is where we can go and define all the information for the part that we're currently working on. So you could say tool steel, we could say the stock height's 2 inches, the wire diameter's 10 thousandths, and I want to do, let's say, 2 skim passes afterwards. Now what that's going to do is it's going to figure out the power settings for my rough, my skim, my second skim, offsets, feed rates, anything I have saved inside of this database. We could even set up tab cuts if we just check that button on. And then when you're done, you could say update save right here, and it's going to save that information for us. So you will want to make sure you set up that database. You might need to go in and edit some information inside that database, and you might not even have a database to output. It really depends on how your machine is going to do it. There's some machines where basically all we're outputting is the path that's needed to follow. And then at the machine, you're going to set up kind of the feeds and speeds, all those EPAC settings. You're going to do all that at the machine. And there's others where we're going to output that into the code. And that's where it really depends on which machine you have. So again, I mentioned this at the beginning. We're only doing a half day today. So I want to point out this page right here. I'll go right back to the start of it, BobCAD-support.com. So this is the website. This is the new tech support training and posting website. It's the same address as it's always been, but we revamped everything on it. You do not need to sign in to see this. So if you don't have a sign in right now, don't worry about it. I do recommend getting one because as time goes on, we're going to expand this website into more and more features that hopefully you guys will be able to use. Again, you go to training here and then down to the recorded virtual events. And when this loads up, you'll see all the available events that you can watch. And I would recommend checking out this one that Andrew did if you're looking at a lot of the settings that are in the system for this. He goes through a lot more of those settings in that one. I know I did back in the one I did a few months back, but that one's probably the most coverage of it because he spent a bit of time on that one. So that's where you can find it. Again, they're all free. These are ones you guys can go check out at any point in time. There's also mill, bob art, laser, plasma, water jet, and lathe. So there they are. We'll leave that there. So now on this part, we have a few options. Now, had I not added in this little tab right here, or the kind of this entryway in, we could have just gone and drilled a hole either wherever, on the inside or the outside. Depends on if we want to make this a punch or a die. But we could have just made a hole, and then in our case, we'd have to drill that hole, and then we'd be able to feed through that hole and make a cut, which we're going to look at with this coreless example over here. So for now, I'm just going to go with a 2-axis open because this is an open shape. And one way to kind of see if it's an open shape is, let me get this out of here, but let me move these 2 lines. I put them on the wrong layer. Just go modify attributes, layer, put that on my CAD layer. And so if I hide the stock layer now, what we'll see is kind of the path that we need to follow. From this straight line, we're going to go all the way around, and then we're going to exit right here. Well, one way to find out if that is a good shape, if it's a clean shape, is go to the beginning of one of your lines, then hold shift and click on it. And what that should do is it should send the chain all the way around, and you should see the whole part light up. So again, you just want to make sure you're sending the chain the correct direction. If I go and look at this line, kind of think about where the midpoint is. If I go to the bottom of the midpoint and I hold shift and click, that's trying to send the chain up to any geometry that connects above that point. So it kind of sends it to the opposite direction. So when you're doing your check, again, find your midpoint. And then if the geometry you want is, say, below this, then we want to go above the midpoint. So the way I always think about it is the longer side of the chain, when I hold shift and click, the longer side is the direction we're going to push that chain in. So if I hold shift and click on it now, it's going to chain all the way around. And that's going to be our geometry for the cut. It's actually going to be the geometry for everything. Whether we do a punch or a die, we can play around with the options there. So I don't need to have that selected now. I'm just going to go over here to the machine setup one, and then right click. And we only have 6 toolpaths for this whole thing. And wire EDM is one of the most repetitive bits of toolpath that I've done in BobCAD. Most of the guys that sign up for the online training for this, they'll ask if they need 2 hours or how much time they need to go through it. And even when we usually book 2 hours, a lot of times we end early and we let them save their other hour because there's just not that much to talk about. There's some settings in here, but really it's, if you're new to BobCAD, I'd say the harder part of wire EDM is probably the drawing. If you're not used to it, if you're getting drawings supplied to you, the wire EDM is one of the easiest ones to do. Now, that's not always the case. When you get into 4-axis, it can get a little bit crazy because you're trying to basically control 2 cuts at the same time. But even that's not too big of a deal with the settings we have in the system. All right, so for this one, because it's that open shape, I'm going to use the 2-axis open. And so basically the big difference between the inside, the outside, and the open is the inside assumes that it's for a punch. The outside assumes that it's for a die, so it kind of automatically goes to the correct side. When we do a 2-axis open and we select our geometry, so I'll say select geometry. And again, the way we pick the geometry is find that point above your midpoint, hold shift and click, and it'll jump all the way around there. Now, just be aware if I did have the stock layer on, it would have chained that as well. So that's why I have it on a separate layer. I only want to see the one. Now, right here, after you pick the geometry, you can click on the chain and you can see where it starts and where it ends. So it's starting on this line here on the right, and it's going to go all the way around, and then it's going to come out right here. And if we want to switch the direction of that, so we come in from the left side and out from the right, we can just go in and say flip the direction, and that's how we're now going to run. So it's all dependent on how you want it to run and really what settings you have along the way. So when I'm all done, I can hit OK, and then I'll go next. Now, right here, it's going to ask us if we want to add a glue stop to the part, as well as the upper lower guide location. So I want to talk glue stop for now. The glue stop is, a point in which we're going to stop the cut. So you have a chance to either glue up your part, throw a magnet on it, do whatever you need to do to keep it from dropping when it's done making the cut. And you could do that right down here. So you have a glue stop with leads and a glue stop without leads. So it's just depending on what you need if you want the glue stop. If you don't want a glue stop, you could just say no glue stop. And the real big difference of what you lose with this is you lose your tab cut because there's no longer a reason to have a tab cut. So it just leaves it out of it right there. So I'm going to go with the no glue stop. Now right here, again, when we choose a 2-axis inside or a 2-axis outside, BobCAD knows whether it's a punch or a die based on kind of the option we choose. So this one, we do have to define whether it's a punch or whether it's a die. And so I'm going to say that it's a die for now. And then right here, we have our taper settings. So by default, we're going to go with no taper on this one. But if we process as a punch or as a die, we have a taper and a land and taper as well. If we process as a punch, we'll see that the land and taper disappears. The punch is going to be more of an outside kind of cut than the inside kind of cuts. But again, we'll go with no taper for now. We'll look at a taper just here in a minute. And then right here, we get to our strategy page. Now on the strategy page, we have 3 strategies, but we have just 3 operations that you can do with any of these features. You have a rough, a skim, and a tab cut. Because we don't have glue stops on anymore, we don't have a tab cut. So on this one, we just have our rough and our skim. Now, one of the biggest problems I see people run into when they're setting up their rough and their skim passes is, a lot of times when you're doing your skim, you're not just doing one skim pass. You're going to do 2, 3, 4 of them, however many you're doing. If you come in here, you can add all those skim passes. And right now that looks great. You got your rough and then 3 skim passes. But you don't actually have to do that. And the reason is on the skim pass feature. So I'm going to get rid of both of these. So I just have my rough and my skim. On my skim pass feature, I can define how many skim passes I want to do. So I don't really mess with anything right here, right now, because I do want to do a rough cut. And even if I want to do 3 skim passes, I can define that later on as I go through my feature. So that's it for that one. We'll go next. Right here's our wire information. So we got the wire diameter. You can enable starting cutting conditions. So this is kind of your lead-in cutting conditions as you start the job. You will usually have to define this with your EPAC settings, whatever you need. And then you have your rapid feed rate. And really all this is used is for calculating time spent rapiding. So not something we really need to worry about. Right here for the posting, you do have a tolerance for your arcs or splines. By default, it's set to 1/2 thou, which is a pretty good place to be. If you need to go a little finer, you can drop that down to like 1/10. If you want to go a little bit less, less quality, then you can go to something like 5 thou. You just got to be real careful with that. The tolerance, and this is the same whether you see it here in wire EDM or whether you see it in mill or mill turn, the tolerance is the allowable deviation. So it's kind of the amount of wobble that's allowed on the part. So in this case, the wire can go 1/2 thou in either direction. If we were to go and drop it to 1/10, it's allowed to go 1/10 in either direction if your machine can hold that. The problem you run into with this one, and it's usually nothing too crazy that I've seen with wire EDM, but it will take a lot more time to calculate. When you lower that tolerance down, you will spend more time calculating. So for now, I'm just going to leave that at 1/2 thou. Got our work offset number, and this one does match the machine setup number that I chose. And you will see that we had 26 of these work offsets inside of the machine setup. So those 26 are going to be stored inside the post processor. You can add more. But inside of the work offset feature itself for the wire EDM, it's listed, and this was inside the current settings, it's listed as 59. So you technically have up to 59. So the big thing with this, if you're going that many machine setups or that many work offsets, you may need to talk to the posting department to ensure that they have the right codes, really for anything past number 26. 26 and up, from 1 to 26 should be defined, but your post could be missing 27 to 59 or however many work offsets you have. So just be aware that that can happen. Otherwise, the work offset usually grabs whatever number we have set up inside the machine setup. That's the number that gets grabbed here. Now over here we have our posting order. Do we go with an individual shape? So do we cut and finish an individual shape, or do we go by operation? So do we do all of, finish one shape with our roughs, our skims and tab cuts and everything, or do we go do all of our rough cuts, then all of our skim cuts, and then all of our, tab cuts, or whatever order we do that in, rough, tab, skim, however. You just have to kind of plan that out beforehand. Usually individual shape, you're not cutting the wire in between because you're just going to retrace the same path back and forth. But with by operation, if you have separate pockets on your part, say it's going to rough the one, cut the wire, feed over to the new position or wrap into the new position, rethread the wire, and then it's going to cut the second part, and then it's going to go kind of jump back and forth. So you will have a lot more wire cutting happening when you're doing your posting order by operation. So I like to focus on trying to get one part done at a time, but certain times you have to get rid of that stock by operation. So whether you use this or you could set up multiple tool paths and kind of just pick singular pieces of geometry, you could manually order it as well. Right here we have our machine sequencing. So what's our sorting order? And this is really useful if you're doing more than one cut on a part, like the next example we'll see. It's going to have more than one cut on the part. So not something I need to really worry about on this one. But you have closest, which is just going to kind of pick a start point based on, or pick the cut based on whatever's closest to the start point we choose. And in my case, I did pick the upper left-hand corner, so I'll leave it there. But closest is just going to cut the closest to the start point, and then wherever it finishes, it's going to go to the next closest location and just kind of work its way around. No sorting sounds very random, and a lot of times it does give you very random movements, very random kind of changes here. Now, the reason it does that most of the time is because of the way that the geometry got picked. If I have a bunch of good, clean geometry on my screen, I have no problems dragging a box over it and selecting it as my geometry. The problem you're going to run into is when you say no sorting, we're going to go in the order that the geometry was selected, which when you drag a box, there is no rhyme or reason on how it picks the geometry. It just knows to grab everything inside the box. It's the same as, picking up stuff on your desk and just reaching two hands out and grabbing everything all at once instead of picking up each individual piece of, notebook on your desk. When you do the no sorting and you drag a box over your geometry, we're just kind of randomly grabbing it. And that's why a lot of times if you do run it that way, you'll end up seeing some very odd rapid moves, or how the toolpath seems to be going all over the place. So no sorting, the proper way to use it, in an example like this picture here, you got 9 pockets. What you do is you would open the you'd say select geometry, you'd hold shift. I would make this into wireframe just because it's way easier. You'd hold shift and then you'd go pick them in the exact order. Another good name for the no sorting option would be pick order. And it's the order that you pick the geometry in. That's the order we're going to run it in. And then we have the X direction, so sort everything along the X. And then we have the Y direction, just sort everything along the Y. I'm going to go with closest. Shouldn't matter too much with this part. Again, until you really do it one piece here. So we'll go ahead and hit next. All right, so we're on to the 2-axis rough cut. And so you'll see right now we just have a standard profile. It's just going to go and cut its way around. What we'll see here is our system compensation. So this would mean that BobCAD is compensating the wire for you. So instead of it being something either you control at the machine fully or just depends on how you want to do it. We can offset by whatever the radius of the wire is so that the edge of the radius is what's running along the part. And you can choose left, right, or off. I'm going to leave that one off because I would control this usually with a G41 or a G42. I believe, I can't remember what I set my start point as. But a G41, if my start point is starting on the left side, right here, to the left will put us on the inside. We'll be cutting our way around the inside. So it'd be like creating a open cut or a inside shape that's going to drop out. So we'd have like kind of a wall left. The G42 option would compensate the other side of the wire. So it would cut the outside of that shape. So I'll leave it on G41 right here. I don't have any stop points applied to this, so there's no resync kind of stop points that we have to worry about. Right here for the corner types, this is not something I make too many changes to, really ever. I have had some customers that make changes to this, but it's just how do we interpolate your internal and external corners? Do we make sharp turns? Like in this case, the part is a sharp corner. And so do we use a sharp kind of, I'd say more of an abrupt movement where we go with like a 90-degree turn? It really depends on the geometry, but like that picture shows there, that's a 90-degree turn, and depending on, feeds and speeds, could be a little bit of a tension builder right there. So there's some options to go in and round the corners so you're not doing that 90-degree kind of sharp turn. We also have a loop radius. So this one's going to come off the part, make a loop, whatever radius you define. It's going to make that loop and then cut back through. And in every corner, it's going to loop those corners. We could do a loop with either the length or the radius. Same options, really, just ones with radius. Then we have a triangle, and finally a bisected line. And this really depends on the kind of parts you're cutting, whether or not you'll even change this one. I can say off the top of my head, I've only changed this a handful of times in, I don't know, this came out, I think, version 2026. I think they revamped it in like 28, 29, or that might have been lathe. Whichever it was, it's been out for a while, and I've only done this a handful of times where we have to change the internal or external corners. The internal corners are down below. They have the exact same options. So rounding the inside, loop radius, loop length, triangle, and bisected line. Now, one thing that a lot of people get confused with on this is the round option. This is not putting fillets on your corners or anything like that. What this is doing is it's just changing how we interpolate the corner. If you have a sharp corner drawn for your geometry, it will treat it as a sharp corner no matter what. So works out pretty good. I'm going to go with sharp there, and then we'll hit next. Now right here for the leads, we have our leads, and I don't have a start hole. We're going to look at that on the next example. So the diameter of my start hole is irrelevant. I'm starting off the part. Thread the wire, I want to thread it vertically. And this, depends on if your machine's got an auto threader or not, but I want to thread vertically. And then right here below that, we have our lead in and lead out. And right now it's set to be the same as the lead in. So looking at this part, with these two straight lines sticking up, it would not be beneficial to me to go perpendicular to those two lines. So what we can do with something like this, real simple, is just change the option. We have a circular, which again, I probably wouldn't use circular. It's not the right choice. We have a perpendicular blend, which could potentially work. It's going to kind of ease its way into the cut. It really depends on where it sets it up, though, because I did not extend those lines at all past the stock. So we're really going to be using these leads right now to kind of add into that stock. All right, so that's how we're gonna set it all up. So I'm gonna go ahead and go with a parallel lead in, and then you just set it to whatever size you're comfortable with. If you want to go, a 1/4 inch away, that's fine. 100,000 should be enough. My wire's 10 thousandths. It's 10 thousandths, so it should be fine to thread outside there. But again, if you needed to, you could come in and change it to something, 1/4 inch, 1/2 inch, whatever you want to do if you want to get away from the part and then feed into it. All right, next we get to our cutting conditions. Now, I want to just say, do not focus on the first cutting conditions page ever. You don't have to. There's always going to be the last page that you go to is always going to end up being the cutting conditions page. And why is that important? Well, because we haven't defined at this point how many skim passes we're going to do. If you're looking at the tree over here on the left, you're only seeing a rough cut and a single skim pass. So what I tell people is don't mess with the cutting conditions right now. If you're going to manually enter in your cutting conditions, it's probably best to have all the tool paths showing. So you could set up your rough, you could set up your skims, and if you have a tab, you could set up your tab as well, and just make sure that you have it set up, the way you want. So I really would just say wait till the end for this one. So I won't even look at what's on that page right now. We'll go next. Right here we have our parameters. So this is for the, sorry guys. This is for the skim pass. And like I said just a second ago, we have not defined the total number of skim passes that we want to run. So right here under the skims, you could say number of skim passes. And I can go with, I'll just say 3. Now above that, you have a few options. One is reverse skims, and that's just going to reverse each skim pass. So if the first one goes clockwise, second one's going to go counterclockwise. Third one's going to go clockwise. Fourth would go counter. So it's just going to switch back and forth. It's going to reverse those skims. You could also say keep everything moving in the same direction, and then your number of skim passes. Now, if your initial skim in the same direction, if you want to keep going in the same direction, but it's backwards, you could say flip pass direction, and it will flip it the other way for you. Right down here for compensation, we are not going to use the system comp. Again, that would be BobCAD taking over and offsetting the toolpath itself by whatever the radius of our wire is. So in this case, it would be just 5 thousandths because I think we're using a 10 thou wire. So it's just going to shift over 5 thou. And then right below that, we have our machine compensation. This is the option I would primarily use because it allows me to make adjustments out at the machine without having to come back to BobCAD to change some offset or anything like that. Again, I don't have stop points, so this button, whether it's checked on or checked off, doesn't really matter. Right here's our corner types. Just talked about all that stuff. Right here we have our leads. So we have our start hole, thread wire. Again, with this one, I'm going to go with parallel. But one thing we could do is if we go back to the leads page we've already set up right here under the 2-axis rough that has all this in it, we can actually just say apply that to all my operations. So I'm just going to click that guy. And then if I go down to my leads again under the skim cut, we'll see now we have a parallel at 1/4 of an inch. So it took the exact same leads as what I had before. That apply to all operations copies the settings from one page to another. And then finally we get to our cutting conditions. Now, if you're manually putting in values into a table in BobCAD, then this is where you'll want to do that. If you don't have a database set up, or you have to have the EPAC settings inside the code, then you're definitely going to want to work with the posting department, see what they can do. I don't know if they can build it. They definitely don't build databases usually. Usually we work with the companies themselves like Sodic or Mitsubishi. We work with them to try and get their databases, but it's not something that they like to give out for free sometimes. So it can be difficult to get our hands on some of the copies of them. But if you have a problem with your posted code, give us a call. Let us know what you're running into, and we can try and figure out what the heck's going on. So again, now that I have the cutting, now that I'm on the final cutting conditions page, this is where I'd go start to try and define those EPAC settings. And this one lets me see all of them. So I can go right here to where it says edit table. And then now we can see we have our rough cut, our 3 skim passes, the offsets, the feed rates, and then what's missing in here is the speed and the tension, which depending on what machine we're using may or may not be needed. So you'll see these all have some values inside of them, as well as their feed rates right there. So when we're all done, we can hit OK. That all looks fine. I'm not going to make any changes on that. Again, if we wanted to, we could change the cutting conditions. You cannot change it when this button is set to link to database. After you uncheck it, you will be able to save it or enter your stuff there. And yeah, there we go. So now that we can't hit next anymore, all we have to do is hit compute. So while this is computing, I'm going to take a little drink break. Thanks, guys. Joey, did you mean to raise your hand? If you guys have any questions that come up, there is I believe the box on your screen is called the question box. It should say questions. It's usually part of the like menu thing. If you guys have questions, feel free to ask them whenever they pop up. I'd rather you not try and save them till the end, because at that point, I'm going to forget what we were talking about. So just add them in whenever. You can throw them in there. And then we'll go through them if we can. So right now, you can't really tell really which side of the line I'm cutting on. It's kind of a center line cut at this point because of compensation being turned off. So if I zoom in on the line, you'll kind of see that the green is just under the wireframe. You can see it when I turn that off a little bit better. So if I did want to see the offset here in BobCAD, because it makes my life a little easier, what I can do, and you have to know you're doing this because this will mess things up, but on the parameters page, you have your system compensation. So I'm going to set that to left. I'm going to apply it to all operations here so that the skim cut gets the same change. And reset my skim passes. So we'll go with, what did I do? 3 skim passes? 2? I'll do 3, whatever. And then I'll hit compute. And so now what you'll see is the tool path, the path itself is reversed. It's on the, you can see where it's going to offset to. So if you want to kind of make sure that you're offsetting to the right direction before you walk out to the machine, that's a good way of just visually seeing it. And what you'll see is it's all dependent on the direction of cut. So if I look at my geometry right here, we can see we're starting here, going around. And if we kind of flip this along with that arrow here, oh man, I flipped it the wrong way. Hold on, let me go back to a top view. And then I just need to spin it a 180 like this. So there we go. I think that's better. So now what you can kind of picture is as this chain is running along, to the left is going to put us on the inside of the job. So it works out fine there. Another thing we can do if we edit this, this start point, let me say reverse the direction, I can recompute that. And now you'll see that the geometry goes to the outside. And I've actually had quite a few people who use pretty much just the 2-axis open for everything, and then they just set it to the correct direction. So it's just whatever you need. There it is. Now I'm going to flip the direction back, so reverse direction and recompute. And then I'm going to go back in and I'm going to turn off the system compensation once again. And then I'll hit compute, and there we go. That'll put it back as a kind of centerline cut. And now to get that to actually offset at the machine, well, when we post the code here, which we haven't simulated or anything yet, so we're really not ready for this, but when we post the code, we get our G41 inside that code. Trying to find the site to watch previous videos and register. Yeah, Joey, give me 1 second, everyone else. The site is BobCAD-support.com. So it's BobCAD-support.com. You don't have to register. That's the big thing we changed with this new site here. So if you get to this page, if you don't have a sign-in, don't worry about it. I mean, if you want to get one made, I don't know what's going on with the registration button, if you can register on the site yet or not. I know there was some stuff going on with it. Right now, the guys in tech support can create you an account. They'll set it up with, I believe it's your email, and then either your they give you the password. It's I think your customer ID or something. You could change it afterwards. But for what you're looking for the previously recorded ones, you don't even have to sign in. Just go right here to training. So again, it's BobCAD-support.com. Go to training, and then right down here to the recorded virtual events there. And as this loads up over here on the right, you should see the wire EDM stuff. Again, if you're looking for ones that go, I'd say a bit more into the settings of wire EDM, I'd say check out Andrew's. We're only doing 2 hours today. Like I said, I have a training after lunch today. That's probably a 3 to 4 hour long one, but he goes through a lot of the settings because we hadn't done that. So he made it a point to tell me that he was going through a bunch of the settings that day. So good. Okay, so there we go. We have our posted code here. And again, you could see that G41 in there. And then the rest of the code is just kind of the rest of the code. The automatic comments are these little comments right here, like the CRT and then EDM, 2X open, skim cut 1 forward. Those are going to be those automatic comments. And a lot of times, if you go into the settings and turn those off, they'll get taken out. It's up to you, though. They've never really caused me any problems. I actually like having them because they're easier to spot as I run through the code. It's one of those things I can see a little quicker to tell me when there's a change in toolpath happening. So this is kind of the end of the rough cut and then starting that skim pass. So I don't need the posting right now. All right, so we didn't simulate this, and I want to pull this back up from what we were looking at earlier because we kind of flew through a bunch of the steps here without kind of looking at it again. So we started our new job, and then we went and did our stock wizard and machine setup. So we defined that rectangular stock, and we defined the origin we planned on using. Now, number 3 is set up the stock material. If you have a database, absolutely you want to set up the material. If you're either manually entering in your EPAC settings or you are setting up all those settings at the machine, then the material doesn't really matter. but it would be best to have the right material showing. I don't do wire EDM setup sheets too much. We're going to look at one. I can't even remember what it's all listed on there. So if it does list the material on the setup sheet, then it's probably best to actually have the setup sheets show the right information. Might make it a bit easier for you so that you know what kind of material you're using for that job. So step number 4 and step number 5 is kind of, hold on one second. So with the setting as is, will it cut the outside or on the line? So Ken has just asked about that. So the setting as is right now, it will cut center line until I'm at the machine and I use my G41 and actually apply the offset. And then after the offset's applied, it should be to the inside of this cut. G41 should put us on the inside. So right now, if I was to go out to the machine and leave my G41 at 0, it's going to do a center line cut. If I was to actually set up a value in there, then it's going to offset it by whatever that value is to the inside, to the left, according to the G41 I have right now. So yeah, I usually do it this way. I mean, I've met a couple guys that do use an offset, and they have the offset here in BobCAD. But I'd say most of you guys that are doing wire EDM, you're doing the full comp out at the machine. So it does make it a little bit more difficult when you are working on it because, like I said, I mean, looking at BobCAD, that's a center line cut. I can barely see the toolpath underneath it. So just be aware that you're relying mostly on that G41 or G42, whichever one you decide to apply it with. All right. So we're talking about this thing down here. So step number 4 and 5 they're pretty much the same things, but it was going through the toolpath, setting up all the settings, just doing the whole wizard that we just ran through. The machining order on something like this doesn't really apply. This is one of those ones that comes in with the mill, the lathe, the mill turn, those kind of things. We do have a machining order, but it's really while we're going through the feature. When we get to the posting page, it's when it asked us if we wanted to do, what were those 2 settings in there? It's real simple. It's right here. It's the posting page right here. This is kind of your machining order. Are you doing the individual shape or are you going by operation? Now, we do have a machining order button. Doesn't really change too much for us, but you can kind of reorganize if need be. Again, individual feature is going to go the order of the CAM tree setup. By operation type is going to group all your operation types together. And then your pass sequence would be, skim cut 1 on multiple shapes, skim cut 2 on multiple shapes, just kind of the passes. And then you can tell it to do your tabs last if you want. Not something I really mess with. Most of the time with this, it's kind of whatever order I set up my cam tree in, that's how we're going to leave it. All right, so back to here. So simulate verify tool assignment. I don't even think that's an option in here. Let's look. It's usually under there's usually a tool crib. So no, there wouldn't be a verified tool assignment. That's fine. All right, so no step number 7. So really step number 7 you don't have to worry about. And other than that, the rest of them we do kind of go through. Again, the material that you choose for the job is kind of whatever. Depends on how your machine sets everything up. So number 8, we'll simulate the final program. Number 9, we'll post that code. And we'll go ahead and set up generate a setup sheet. So after you have your toolpath done, and you can see it, you can start the simulation. Before you start any simulation, though, just give it a save. If you don't have it saved as a BobCAD file for, at the start, save it as a BobCAD file. The reason I mention that is if you open up a part, maybe a customer sends you a part and it opens up from a DXF, a DWG, an IGES, or a STEP, any of those 4 file types, we have the ability to save as those file types as well as export them. We can import and export them. That's a better way of saying it. So what ends up happening is if you apply all your toolpath to it and you don't go in and hit this, and you don't do a save as to save it as a BobCAD file type, then as you hit save, it will be saving the part. But it'll just be saving the geometry on the part. It won't actually be saving any of the toolpath because a DWG, a DXF, an IGES, and a STEP, they don't have the ability to save our toolpath. So you have to make sure if you add any toolpath to a job, you need to be sure to do a save as And by default, it's going to try and save it as a BBCD, the BobCAD file type. So a lot of times, if you're putting it in the same folder, you just hit save as, and then you'll hit save. And in my case, I'm replacing with one I already have. So I'm just going to say, yeah, go ahead. And there it is. So I always recommend that before you run the simulation. And if you're doing 3-axis milling toolpaths, I recommend saving every about 2 minutes or so. Not really. But really, for me, it's anytime I finish a toolpath, I like to save. And then before I run my simulation, I like to save. Just in case, I'd rather not lose my work if something hits too hard on the simulation. I'm especially vulnerable. Like today, I'm recording with this go-to meeting software, and it does horrible things to my computer while it's recording. So yeah, if anything locks up, it's usually that's the cause. But we'll get started again. Save often. All right, so right here we have just the simulation. Most of you guys have probably been in here before, but we have our material removal mode. That means we're going to see the material taken away from the part as we cut around. I always leave it with length mode. When you get into 4 and 5-axis milling, that changes things, but length mode is the truest view you're going to get of kind of how the part's going to move around. A lot of the default settings, I believe, are set to NC mode. The problem with NC mode is any straight line that you have is kind of just an immediate movement. It doesn't show the wire cutting through that line. You'll see it at the beginning of the line, and then a split second later it'll be at the end of the line. It just kind of jumps through it very quickly, and so it can get kind of difficult to see exactly what's going on. So yeah, I use the length mode option, and then I use workpiece stock. Workpiece stock is going to lock my part in the screen, and we're going to see the wire cut through, and you can actually see the wire right there. I'll show you another way of seeing the wire here in a second. Here's all your playback options. So you got run, stop, previous op, step back, all that stuff, fast forward, step forward, and this will be, line by line. The next op option will move you to the next operation here in the move list, and then you have your simulation run speed. I always like to turn it down at the start, and then as I run, I'll turn it up if it seems too slow. Then right here for your views, you have just fit everything to the screen, and then your ISO views, your top, front, right, bottom, back, left. You also have the cube down here in the corner that works out really good for views. You could actually just click on an edge or a corner, and it will line you up with that. So that's a top view. If I go and pick this corner, I can get an isometric view right there. So I'll just say ISO 1 or isometric, and it sets me back up. But you can use that cube to change your view here in the simulation. Next to that, we have our visibility. Visibility for this one, you should have your toolpath on. That one's fine. The tool itself is just the wire. And then I do want to show the stock. Now, if you want to kind of see, that wire is a little bit tough to see when you're looking at your part. You also have an option for the machine housing here. And if I turn that option to show, that's how you turn your guides on. So you can see the guides of the wire. Not too much of a difference, but it does help when you're trying to kind of just see where the wire is at any given time. The last bit is the toolpath rendering. Now, the reason I'm okay with having the toolpath on all the time is because under the toolpath rendering, right here, the initial option that you have set up looks something like this. This is what the defaults are going to look like. I go into where it says all op, and I change that to say just the current operation. So it's showing me just the current operation. And then I change it from showing me the entire toolpath to just a segment of that toolpath. And so as this runs around the part and makes its cut, it's going to kind of show you the path that's coming up. And as you cut that path, it's going to disappear behind the wire. So it does make it so you don't have to turn off your toolpath every time. Other than that, the biggest button I say to be careful with is actually it's on the Measure tab. And when you click on the Measure tab allows you to measure points and distances, and it's not something I use often. It's, to me, not accurate enough for anything I'm doing. But you have the options below that are saying remove chips. So the remove chips is used by clicking your middle mouse wheel like a button. The problem that you'll run into is a lot of times I click the middle mouse wheel when I'm trying to rotate my view, because that's how you rotate your view inside of, the BobCAD, not inside the simulation. Inside the simulation, remember that it's a left click and drag. So you're going to left click, hold, and drag to rotate. This measure feature uses the click of the middle mouse wheel to remove material that's left over. So I'll show you that when we're all done here. Other than that, the rest of them, not too important. Statistics, not going to get much from that with wire. So yeah, really it's the move list just to see what operation you're on. And then for me, it's just the measure tab. And I like to just make sure that that's set to off right at the start so I don't accidentally get rid of some stuff. So now that that's done, we can go ahead and say run. And this is where I always start a little slow and then I can speed it up a bit. And you'll see if we go and turn off the machine housing, which is those guides, you're just going to see the wire kind of cutting through the part there. So we'll speed it up a little bit and just let it run. So this is all just part of the rough cut right here as it gets its way around. Now it's going to start its first skim pass, as we can see from the move list. If we flip this part upside down, we should be able to see the bottom getting opened up as well. And that's one of the biggest things you want to pay attention to for this next feature, which is under that measure tab that we're going to look at. We need to make sure that there's no connections between the walls. So if you use some funky leads, once in a while, it'll have, a little triangular segment that might be still touching the rest of the stock. What we want to be able to do is look through the part and see kind of the gray on the other side over there. That's going to ensure that we're cut all the way through. So if we go look up here, that all looks great. So now what I can do is, kind of depending on which side of this I want to keep, I'm just going to rotate this around again. Let me get to my isometric here. There we go. And on the measure tab, I'm going to say remove chips. And I have really with this one, I would choose from two choices. You either have select chips, which is whatever you want to get rid of, you're going to click on. Or you can do the remove chips, only keep one part. And that's going to be whatever you click on is the only thing that's going to stay on the part. So I'm going to go with the remove chips. I'll say select chips. And I want to get rid of this inside, the inside of this thing. So I'm just going to hold my mouse over this piece of geometry. And then using the mouse wheel, the zoom in and out mouse wheel, I'm going to click it like a button. And because I'm on select chips, I'm selecting that this is what I want to get removed, and that's what it'll do. After you're done using it, turn it off. There's nothing more annoying than accidentally coming in here, going to rotate and using your middle mouse wheel to rotate, and then you delete all the geometry once again. So there it is. There's our die for that part. All right. So from there, we can make some, whatever else we need to do to that part. That would be it. After that's all done, we would then come over here. We'd right click on the wire EDM job and say post. There's our code. To save that code, we just right click and in the code and then say save as. And this is going to let us save it wherever we want to go. The last bit is a setup sheet. Now, if I say generate a setup sheet, we have a full setup sheet, and then we have wire EDM setup sheets specifically down at the bottom. I usually use the full setup sheet for everything. Let's give it a try, see what it looks like. So I'll just hit OK and see what kind of information it gives us. Otherwise, we will have to use the wire EDM one, but that looks pretty good. We got the gear, we got our post, our machine, the date and the time, program number, units, cutting distances, total cycle time. Now, the total cycle time is based on I don't know what calculation. Usually it's your feed rates and everything, but we don't really have any of that defined here. So let's close this down. Let's see what the wire EDM setup sheet looks like. If it gives us any better information. I don't think it does. I think they're pretty similar. Yeah. So it does have more options to it, more lead options. You can see all that stuff, your start holes, all that stuff. Pretty much everything we have. Not sure why we have a tab width right here because we don't have tabs. That might just be what it's left as. Yeah, probably. And then we have all of our skim passes and the breakdown of all that stuff. So you can see it's got the power setting. These ones don't have anything. I didn't apparently enter that in. There it is. So after you're done with this, when you do generate a setup sheet, easiest way to save it is to right click and then go down to print. All right, now if you're using really Windows 10, I can't think of many people who aren't at least on Windows 10 nowadays. If you're on an older version, you might need to get there's software for it. But on Windows 10, they actually created this Microsoft Print to PDF option. And it's real cool because you just say print, and instead of it printing out to your printer, it's going to go create a PDF that you can open up at some other point. So I could go desktop. Let's go repeat training right here. Let me find my folder here, part files, wire EDM. So right here, I can go in and say this is the gear setup sheet, and then say save. So now I could go open up that PDF whenever I need it. I could either print it out or I could just reference it right from when I open it up, and we're done. So there we go. All right, so we'll close that out. All right, let's go ahead and look at some 2-axis coreless cutting. So with this one, I had to set up the stock a bit better. I wanted to make it so it was more realistic. So over on my layers here, I have my CAD layer and I have my stock layer. So I'm going to move my check mark down to my stock layer because you cannot turn off a layer if that green check mark is on it. I'm then going to just hide the CAD window, the CAD layer right there. So what's left is my stock. And just to make it look a little easier, let's do this. I'm just going to turn off my axis XY here, just so we can see. So that is the stock on the outside, just a rectangular piece of stock. And then all those holes that are in it are going to be holes that I've created, that I've drilled into this part already. Those are going to be my start points for all of those, for all the rest of the features. The rest of the features are going to be these pockets here and these 3/8 holes here. All right. So I'm just going to go over here and start my new job. Again, if we're going through the same steps of this kind of cheat sheet, we're back at step number 1. We start our new job. We go to wire EDM, and we go right here to the stock wizard. From here, this is where it asks about a workpiece. And again, I don't have a workpiece for this one. A workpiece would just be a solid model that does represent the final kind of finished part with everything right here. All right, so our stock type, there it is. We're going to use rectangular stock. You'll see this is 7 by 7 by 1. That's fine. If we want to go thicker or make it bigger, we can do that. I'm just going to go and focus on cutting these holes. Now, 7 by 7 by 1 is fine, but I can't get those holes to show up through the part. And I want the holes to be there because they're part of the stock. That's what I'm going to have on the machine when I get there. So rectangular is not a bad option. It would just take some imagination when you're watching the simulation to know that these holes are already in there. So another quick, easy way to do it is to use this third option over here, the wireframe. Wireframe allows us to just drag a box over all the geometry and then do a calculate. And it's basically doing an extrusion. It's taking those holes out of the part. I don't have to define the 7 by 7 anymore because it picked the square. And I could go in and change the height. We'll go 1.5 inch. 1.5 inches right there. And the extrusion direction is in the Z-axis. So from there, we'll hit next. Now, if this is the part that I have, if this is what I'm using, I'd probably try and locate off one of these holes just because they're already in the stock. And if I did everything right, then all those holes are already in their correct position. So something like this, I could pick this origin and say I'm going to set it on the center of that hole right there. And that's where all my code's going to be based off of. All right, we don't need multiple start points. It's going to cut the wire and feed through all the rest of these, as long as your machine's capable of doing that. And then when we're done, I'm just going to hit OK. And there we have it. So there's our wireframe piece of stock. And then these are all kind of the cuts that we're going to make for it. So with this one, these are all inside cuts. So I don't have to do any open or outside. But we'll go 2-axis inside. And then I'm just going to select my geometry. Now, again, because of the way I set all this stuff up, I can come in and hide my stock. And that way there's less for me to select. I can't pick any of those 1/8 inch holes that I had in here. But I am still going to hold Shift and click on every shape. So right there. Now the arcs, you don't really have to hold shift because they're all just single pieces, but pick them however you want. You could hold shift or not hold shift. It doesn't really matter. And then right here, we have our chains. So what I usually like to do with the chains, especially on wire, especially if I'm going from a certain point to a wall, I would go and say, let's start at the middle of the longest entity and let BobCAD figure out which one's the longest entity. And if you want to keep it uniform, you can always click around and move those start points to wherever you want. You know, even on these arcs here, I could just click and move wherever I want it to be. All right, so we'll go ahead and hit OK and then go next. So with this one, I'm going to do a tabbed cut and I'm going to do a coreless cut, so we could kind of see the difference between them. And so this one, we're just going to do we'll just do a use glue stops, and then right here we'll set the stop distance at, I'll leave it at 100 thousandths there. So that should be fine. So this is going to leave a tab on the part that's 100 thousandths, so these parts don't drop out immediately. So I'll go next. Right here, we now define what type of cuts we're doing. So we're going to have our rough cut, we're going to have our tab cut, and then we're going to have our skim cut. So we'll go next again. Ooh, it's loading. Back to the wire settings. It's just kind of enable starting cutting conditions and the rapid feed rate. I'd have to look at my wire diameters just under 10 thou. Look at that later on. Right here for the posting, we have our arc tolerances again, our work offset number, and then our posting order, just by individual shape or by operation. Next, again, we have our machine sequencing. So this one's not a bad one to go and say no sorting, because I did go and I held shift and I went and picked each one of those shapes kind of in the order I wanted it to cut. So I'm just going to go next again. Now, right here, we have our rough profile. And because we're not doing because it sees this as what would this be? A die? No, a punch. We have a standard profile, and then we also have coreless. But I can't use coreless if I have a glue stop set up. So we're going to come in and change this here in a few minutes. But there it is. Now, in this one, you'll see we have our system compensation, but it's not a setting to go left or right. It's just on or off, because the system will calculate whether it's going to be a G41 or a G42 based on which direction we have our start point set up. But it knows that it's cutting the inside of the shape, not the outside. So it's just an on or off for the system compensation and an on or off for the machine compensation. Next, again, we have our corner types. So it's no changes for me. I'm going to let it follow the geometry. I'm not trying to interpolate the corners in any other ways. Right here's our leads. So with this one, with what we normally would do is select points. That's probably the easiest way to do this, and there's an even real quick way of grabbing them all. But if you could fit a different lead into here, like a perpendicular lead or something, and you knew the distance you wanted to go, then you could enter that in. But select point is probably one of the best options because it's multiple point. You can use multiple points on it. So I'm going to go with select point and then pick points. And when we do pick points, it's going to load up the CAD tree. And what you'll notice, or it's the data entry tab, what you'll notice is right here on the left, the only option that's available is the point mask. It automatically turned this on for me. So all I have to do is drag a box over all of the points on the screen, and it's going to select them all. When I'm done, I can hit OK. Now, there is an option for this one that the way I set up my start point should give me a good result, but right there you have an option called perpendicular to closest. The thing you have to be careful with this one on, though, is we don't always want to return to those start points after our rough cut. We might want to stop. So one thing that we could do is say, for the lead out, instead of doing a select point, you can go with just a perpendicular lead out or whatever makes sense. I'll leave it on for now, but a lot of time, or actually I'm going to set it to, let's go from where we are, we'll go perpendicular, and I'm just going to set it to 50 thousandths. All right, so we have our lead in starting at the point, so it'll thread through those holes, and then it'll feed over to the part. The problem is if I have the lead out set up as same as lead in, then what's going to happen is it's going to finish the cut 100 thousandths early, so you'll see this more on these arcs. It's It's going to come over here. It's going to cut, go halfway. It's going to go almost all the way around. And then it's going to stop and lead back. So the slug that I have is still going to drop out because it's making a complete closed cut. We just make a, it look like a Pac-Man instead of a circle. So we want to make sure that on the lead out, we do something a little different so that it just leads straight out. So we'll do a perpendicular. Again, I'll set it to, I'll go 50 thou, and then I'll go next. Right here for the cutting conditions, remember, leave this for the last cutting conditions tab. There's no reason to set it up now. Just keep going next. Right here for the tab cut, we could tell it to just do a standard profile. Remember, this is just cutting off that, what did I do, 100 thou tab that we left on the part. So it's not something we got to worry about doing some crazy thing. It's just a standard profile. Just go cut it. But we could tell it to flip the pass direction. So just flip the direction of which we cut the tab in. Compensation, once again, if system comp is off, it will look like a centerline cut until you know, and then when you post the code, you'll get that G41 or G42. Again, that's all dependent on the direction that the arrow for the start point is going in. It can be either G41 or G42, depending on what you have set up. Right here, we have our leads. So for this one, just going to go with a parallel or a perpendicular. I'll say 50 thou for both of them. So this should just kind of thread the wire, make our simple tab cut, and then run it that way. And then finally, cutting conditions, once again. And then the skim passes, we'll just say let's do 2 of them. And we'll just knock this one out real quick. So no changes on the corner types. No changes for the leads. Should be fine with this. The tab should be gone. So we'll go next again. And then finally, when we're done, we just hit compute. And I'm going to take a drink. All right. So for this one, if we were to go, let's blank out that stock right quick. We'll go to a top view. And I'm just going to blank out all the toolpath as well. That wasn't a top view. There we go. And so here's our rough cut. So it's going to cut in. It's going to go around, make its cut, and then it's going to stop right there. The tab cut is then going to come in right here, make that tab cut right to the same position. So it should slice that section away. And then we're going to have our skim passes that go in. And again, you can set the skim passes to go to the select points page, you know, to the points themselves, or you don't have to worry about them too much. All right. So there's that one. All right. So that's all those. They're all going to be pretty much the same. And so let's go ahead and we can simulate that one. Let's give this a save. I think I got that in the right folder. Let me make sure. Nope. It's V34 wire EDM. There we go. So let me save that guy in there. Perfect. All right. Excuse me. Now we'll go ahead and start the simulation and we'll see it again. And while that's loading, again, this is going to be a shortened day. We only got about 40 minutes left or so. We're going to stop at lunch. I have a training to do afterwards. So for anyone who just joined, because I think a couple of you guys just joined in, I just want to pull this up one last time. I'll probably do it one more time at the end too. Website is BobCAD-support.com. All right. It's a new site. We just came out with it within the last month or so. If you have a registration for this, if you've already talked to tech support about it, go ahead and log in with your registration. That'll be just fine. That way you get the most up-to-date info on your Training Professor series. If you own any versions of our Training Professor videos, they will automatically show up here after you register and log in. But what I want to show you guys is I'm not logged in right now. If you go to training and down to the virtual events here, this will let you watch all of the previously recorded virtual events. And you'll see right here, we have a whole section for wire EDM. If you're looking for more of the settings for this, I believe Andrew went over it. This one right here, the one on 727 here. Andrew, I know he spent a lot more time on one of these doing a lot of the settings. So that's where it's at right there, just BobCAD-support.com. And then again, under training, go to those recorded virtual events. All right. So now that we have our simulation up and running, we could see the holes in the part, and we'll see as we run this, we're starting in that corner there. We should be doing the 4 squares first because of the order I picked everything in. It should go in the order I picked it, so I should be able to see all 4 of them. But you'll see the way I got it set up now is it's going to do its rough cut, then its tab cut, skims, and it's just going to skim its way around now. And there we go. Now, one thing there is, it's over here under measure. There is an option called remove chips based on volume. Now, this one actually runs while you're running the part. If you check on this button that says automatically remove chips during simulation. So if I turn that on, it should automatically, oh, I got to refresh this. So it's remove all small chips, keep the largest one. And let's say run. It should be disappearing as we cut. There they go. And then you can kind of see where it would have fallen out at. So there's our rough cut. Didn't fall. There's our very quick tab. We're just going too fast to see the tab move. So let's go here. We're all the way around. Right here's where it ends. And then it does that tab. And then it disappears. So that'd be just at the same time it'd fall out for you guys. Just like that. So now it's going to do those. And then it's going to open up these 3/8 holes we have right here. But the way I really set this one up, and another way that we could cut this, instead of doing these tab cuts, is to go into a coreless cut. It's not something I run into often. Most guys are using it to open up holes, kind of bring them to size. But you could use it for whatever. Another thing we could do is do these 4 squares here, the way we're doing them now with the tab and the skim passes, just the way we have it now. And we could actually do a second feature for these inside holes, so we don't have to mess with anything. But what I'm going to do, we'll just do a separate feature. So now let's say I want to do these center or these 4 squares that we have on here. The way I got them working out now is great. I'm good with that. But I've already picked all the geometry for these guys as well. Well, that's an easy fix. All you do is right-click on the word geometry. And I usually just do a reselect because I can come in and just deselect the arcs here. But all the other settings that I have for my start point should stay the same. You could also just remove the geometry, reselect all the geometry, and then recompute it. But we'll go ahead and hit OK. And we'll just compute this toolpath. So now it gets rid of the center cuts that we have going on with these arcs, and it's going to leave just the 4 squares. So now I'm going to go ahead and do another 2-axis inside. This time I'll just select the geometry as everything but the point. So you'll notice right here, this is your selection mask. I mentioned it earlier, but the point mask is currently turned off, meaning if I tried to drag a box over a point, nothing happens. So I can just drag a box over all 4 of those arcs right there, and it's only going to grab the 4 arcs. And you can verify that by looking right here under Selected Geometry. We have just 4 arcs. Right here we have our start points for them. I always like to just click in this box and give it a quick glance. That's fine. I'm good with where they're starting. And so I'll go ahead and hit OK. Next again. So for this one, we're going to do no glue stop. And we're going to go ahead and add a little taper to it just for fun. Now, when you're doing a taper, whether it's a taper or a land and taper, the difference between the two is a land is going to have you define the land height and a taper. But when you're doing your tapers, you have a negative or a positive value. So a negative taper angle is going to go to the left. Positive is going to go to the right. So you just want to make sure that whatever value you put in there, it's either going to be positive or negative. Really not too difficult. If you get it wrong, just go in and put a negative or get rid of the negative. Just flip-flop it, and it'll usually come out fine after that. So we'll go ahead and go next. Right here we have our cuts, so we're just going to do a rough and some skim cuts. So next again. Right here for the wire. No changes on the wire. Just going to go next again. No changes for the posting. Next again. Machine sequencing. We'll go no sorting, not that it matters too much. And then right here for the patterns. Now, because I'm doing a tapered cut, I can still no longer use coreless. So let's go back in. I want to do one coreless one right here. There we go. So we'll look at the coreless and we'll jump back in and do a tapered cut. So right here's the patterns. You got your standard profile or your coreless cut. The way you can think about this is standard kind of profile or kind of like a pocketing routine where we're going to take, we're essentially making the entire part chips. So we could go with a coreless cut. And with that, you could set up a step over. Now, this is for your wire, so you want to be pretty small with it here. We are doing skim passes to clean this up afterwards, but I'll go with a 50% step over for now. Again, compensation with this one's either going to be on or off. So on either one of these, it's on or off. It's all dependent on the direction that you're cutting in. Right here, we have our, what did I turn? Yeah, I got that on. Right here, corner types, no changes. I'm just cutting some arcs anyway. For the leads, it's a coreless point, or it kind of automatically figures it out. So we could say select point, and then for the lead out, I'll also do a select point just to let them go. And so I'll select my points for this. And again, this is only these 4. So as long as I don't grab anything extra, we're good. For the lead out, we could just go perpendicular, right? There's no reason we couldn't go perpendicular. I'll just go perpendicular. Now, this is where the start hole diameter finally comes into play. The diameter of the start hole is what you want to define for the hole size that you drew when you created the part. Because in some of these, like if I was really using a coreless on something like this pocket here, I might go in and drill a big hole in here, feed through that hole, and then do the coreless cut to clean up kind of from that diameter of the big hole to the walls. So you definitely want to define either the diameter or go a little bit under the diameter. The holes that I created are 1/8 inch. You can see them right over there. I measured them before we got in here earlier. And so the diameter, I could either go with an 1/8 inch, or I could say something like just 100 thousandths. Go a little bit smaller. I might cut air, excuse me, on the first couple passes. I'm fine with that. I wanted to just slowly get into there and do that coreless cut for me. So I'll go ahead and hit next. Right here, again, the cutting conditions, if it's in the middle of the page, ignore it. We're going to get to this cutting conditions before we worry about it. For the skim passes, again, I'll just do 2. Compensations all applied. Right here, we have our corner types, no changes. Leads, really with this one, we're not leaving any tabs, so we should be able to, just go perpendicular into this. We don't have to worry about the start hole because we're not going back to the start hole. And finally, the cutting conditions. So this is where we would go and edit the table and make any changes to the cutting conditions. And when we're all done, we can hit compute. And there they are. You can see it's a lot more path, but now we don't have a slug dropping out of this hole. It's going to turn that whole thing into chips. So if we turn our stock layer on, as you can see, the blue that we have right there, that's my 1/8 inch diameter hole. So we're going to start on the inside and just kind of work our way out. A couple passes are wasting time for us, but that's not that big of a deal. We could also change the step over amount. I'm at 50%, so it should be about 5 thou per pass. So that's what will be taken out. And there it is. So now let's go ahead and save this. Again, always save before you go into the simulation. We'll go ahead and save that. Start the simulation. And there it goes. And then we'll fast forward. The first ones here should be the big square. So we're just going to go down to the point where we have no more tab cuts happening. Man, a lot of operations on this one. Skim pass 1, 2, tab cut. Let's see where op 15 takes us. All right, so these should be the last couple passes for those. So there it is right there. Op 17 is the one we need. So the wire is actually already in the middle of the hole. That's kind of where it started. We'll say run. And so you'll see it's going to open it up from there. Now, one thing to note with the simulation, while it's running, the quality it kind of lowers itself. As you can see right now, it's kind of jagged looking. Just wait until the whole thing's done and it'll clean it all up. So we'll speed this up a bit. A little faster. There we go. And then as it finishes that, we're then going to do our 2 skim passes and then move to the next one. So again, while it's running, it's going to look pretty bad. There it is there. But as soon as it finishes, you'll actually see it down at the bottom of the screen, this automatic quality improvement. That's trying to clean up that geometry for you so you get a good view of it inside the part. So there it is. So real simple part, but a couple different methods of doing it. So now let's actually do the tapered one, because with taper, we can't do the coreless option. We lose the coreless option when we go to try to add a taper to it. So I'll just taper out those 3 holes. Just going to say taper. Again, when you're doing your taper, negative is to the left, positive is to the right, and that's based off of the direction you're cutting in. just like the cutting condition, or just like the compensation. It's all based on which direction you're cutting in. BobCAD, if you're cutting in, let's say clockwise, and you want to be on the outside, it'll set a G41 to go to the left. If you want to be on the inside, it would set it to a G42. It's all about the direction of cut. So we'll go ahead and hit compute. I'm not even going to change anything else on here. Is there anything I need to change? I don't think so. Parameters, so we can't do coreless anymore. We're applying our taper for this. The leads, perpendicular. The leads, let's change. We're going to go to select point, pick points. It's got them picked already. It just didn't remember that. And then, yeah, that's it. So we'll lead out perpendicular. No, this is going to be same as lead in. So we're going to go back to the center point at the end. We don't have tabs on here. And it does know the diameter of the hole, but that doesn't really matter here. We're not doing a coreless cut. And so that's good. That's fine. Leads, once again, shouldn't need these actually, but yeah, we'll just go perpendicular on those. So we'll compute right there. So what is our direction of cut going as? I got my 2-axis inside. What do I got going wrong? Oh, that's the bottom of the taper. All right, so this one shows up a little bit different. So I'm going to turn off my layers real quick and hopefully show this a little better right here. So there is 2 lines on this one now. Totally forgot about it. Forgot we did the taper. This is our top edge, and we're tapering down at the bottom. You could actually see it right there. Or actually, that's the bottom. We're tapering up. Oh, taper from bottom. So if I want to taper from the top down, I just uncheck that button. Forgot about that guy. So compute, there it is. And so there we have it. We're going to be wider at the top than we are at the bottom. Or if we uncheck that button and recalculate, it's going to flip that. So I'm just going to hit save here. And then I'm just going to turn off the squares. I'll say post yes, no. And we'll just simulate that one real quick. Again, this is a positive 3-degree taper. So just let this load. And here we go. So now this, I'm just going to let this run through. We're not really going to see much with it. Pretty much the same as all the rest of them. But if we go to a top view when it's running that, you could see it's got that taper to it. Now, there we go. All right, if anyone has any questions, feel free to throw them in. I'm going to open up kind of a goofy example that I have, but it allows me to look at some, I'll show you guys some 4-axis real quick, because a lot of times with not land and taper, but tapered, even 2-axis, depending on how your parts show up, sometimes you get better control if you actually run them as a 4-axis shape. So I'm just going to open up, I got a part file here. Let me find it, there it is. And if you've been in one of these with me before, you may have seen this part actually. It's one of my favorites. So this one has all of it. So the part file itself is this big old solid model here. And some of these are just tapered. I can't remember. I believe it's this one here is just tapered. And I believe that U-shaped one down there is just a taper. So we don't need it. But let me hide all this stuff. I got a lot of layers on this one. So there's our solid. So if I wanted to cut, say, this shape here, where it does blend between the two, separate shapes, then we're going to use a 4-axis move. And I'm going to shrink this whole thing up. And real quick, just new job, wire, stock wizard. And I'm just going to recreate the stock on this job real quick. So I'll go ahead and hit OK. Great. So there we go. Now, normally at this point, I'd come in, I'd start adding points for any holes that I have in the part, anything like that. So we'll go ahead and let's look at this guy right here. It's got a little land and a taper. I don't know what the taper angle is off the top of my head, but we could play around with some values and see. Before I go and do that, though, working with a solid, totally doable. You're more than welcome to do it. But what you'll see, and I've done it over here, but I'm going to add a new layer. Let me make this a little bigger here. I'm going to go ahead and add a new layer, and I'm just going to call it top geo 2 because I already have one of these and you can't use the same name. So there's my top geo 2. We'll say bottom geo 2. Whoops, that's the at symbol there, 2. All right, now when we go to do this, to pull the wireframe off the top of a part, I'm just going to go to Create 2D and Extract Edges. I'm going to pick that top surface, just the whole thing right there, and then I'm going to hit OK. Then I can move my check mark down to the bottom geometry layer that I just made, pick that bottom surface, hit OK. Now if I hide that solid, I'm left with a lot of extra geometry, which is fine. We have a real quick, easy way of kind of cleaning that up. All I'm going to do is hold Shift and pick the 2 shapes that I want to work with. So they are the only 2 selected. Then I'm going to drag a box over everything else, including the 2 that I selected, and it'll deselect the 2 I had selected, and it'll reselect everything that wasn't selected. And then I'm just going to hit Delete. So there we are. Now we have those 2 little pieces of geometry kind of isolated. Now, if you know your taper angle, which I don't, we're going to try it. We're going to do a 2-axis inside, select my geometry. I'll just go ahead and pick this right here. I'm just going to pick that top shape. And then we'll say for the start point on this, let's go right there. Whoops, right. Let me go to a top view and try and pick that. Come on now. There we go. Good enough. That'll work. All right, so we'll hit OK. And then I'll go next. Now, I'm not going to do any glue stops with this one. I'm just going to do a little land and taper. Again, I don't know the angle, and I don't know the land itself, but I'm just going to set this to 1/8 of an inch for the land height. The land is going to be on top, and so we're then going to do a 3-degree taper angle from there. Right here we have our rough and our skim cuts when it loads up, just a rough and a skim. We do need both of them. As we go through our landed taper, all the rest of it's the same. You know, everything we do is pretty much the same. But right here, we have to tell it which pass is going to apply the taper. So for me, I got my rough pass going in and applying the taper. So that's going to do the tapered cut. And then the skim cut is just going to do the vertical, which we'll see here in a second. So as we next our way through, no changes to corner types. Leads, I'm just going to go with perpendicular. I'm just going to set them to 50 thou, though. I don't know how much space I have here. And then right here for the skims, we'll just do 1. But you'll see the taper settings on this one. It's not applying the taper. So this is just going to do whatever the land is around there. No changes there. Again, for the length, I'll just go with 50 thou for my lead in and lead out. And then cutting conditions. So I'll hit compute. And there it is. So I'm off by a little bit with my taper. Probably, what is it, 2.5 or something? Let's try 2.5. Might be a little less than that. Hey, that's perfect. Looks like it's about a 2.5 degree taper on that. So without even selecting that bottom piece of geometry, I now have, you know, both of them done. You know, granted, I'd have to figure out a plunge point and everything for that. So that's one way of doing kind of your tapered cut. Now, this one's a land and a taper, so it kind of doesn't count. But another way of doing it, especially if you're already at the point where you have geometry kind of separated out, is to go with a 4-axis. So we'll do a 4-axis inside cut. And this one's pretty straightforward. You pick an upper profile, which is going to be the smaller shape here. So I'm just going to hold Shift and pick it. And then you pick a lower profile. Again, hold Shift and pick it. And then in your chains, the biggest thing is trying to get these to line up. I want these start points to be as close to each other in line as possible, which can get difficult when you're doing goofy shapes like that. There's that blisk right here. It's real difficult to get these 2 points to line up in the right spot. Or I wouldn't say it's difficult. It's hard to pick the points. I struggle with it almost every time. Now with 4-axis, if you had lines that were connecting the top to the bottom, which the solid model does actually have these, all these lines here, we could use as sync lines. But if we don't have those by default, which I don't have them by default, and I'm fine with that, when we hit OK and we go next, we have some options for syncing. So you can go, let me turn off the glue stop. So you can go by entity. So it's going to kind of basically count the number of entities or kind of what lines up close. But really, it's kind of the count of entities, and it's going to try and match them up. So if the top shape has 4 entities, the bottom shape has 4 entities, it's going to come out pretty good. If the top shape has 50 entities and the bottom has 4, it could give you some weird sinking lines and you might cut corners, and that might not be the way to go. By proportion is going by the proportion. It's looking kind of proportionally at the two parts and just basically where it starts and where it ends. Honestly, I'm not too worried about this part having syncing option issues because it's essentially one part just offset out. So most of this should sync up pretty nicely. But we also do have closest. So closest would be, this point here is closest to that point there. So it's going to sync at those points. For this one, I'm going to go with by entity. But honestly, I think any one of these ones should work with this part. Right here, we have our strategy. Same strategies. So rough and skim. We're not doing any tab cuts. For the wire, it's got that 098. I just didn't change it. Right here, we have our tolerance, our number, and our posting order. Great. Right here for the parameters, just a standard profile. Again, because we've defined that this is a 4-axis inside job, it knows which way it needs to move. Not applying any stop points. For the leads, I'm just going to go with the same 50 thou leads we used before. Just say 50 thou there. Right here, force vertical means that before it finishes the part, it will make itself a vertical wire. So it'll actually shift wherever it's needed to make it a vertical movement on the way out. So I'd expect it to see that line kind of right where I set those start points. It'll line back up vertically. Whoops, almost lost the whole box there. All right. Cutting conditions, again, wait till the last page. Parameters, I'll just do the one skim pass. I'm not too worried about it. Leads, once again, just going to set that to the 50 thou. And finally, the cutting conditions right there. So this would be the time, if I was setting up my cutting conditions, this is when I would do it. So I'm going to go ahead and hit compute. And there is the taper. Now there's no land on this one. It's not something I added in. You could go just do a straight cut if you wanted to now. It's no faster or slower. I mean, it's slower than doing a land and taper. But the benefit of this one is if you don't know what the taper angle is. We got lucky a few minutes ago. I just guessed it at 2.5. It could have been 2.47 or something weird. If you don't know it, this is probably the best way to go about getting it, because this one's going to kind of calculate that for us. It's cutting two individual shapes. So let me just go ahead and turn off the other job completely. And this only has the 4-axis. So I'll give it a save. And we'll give it a start simulation. No operation is defined. I got an operation defined right there. What are you talking about? Huh. Let me try this again. So let me just, all right, so let me save this. I think it's the wire, I get the second job here. So let me delete that whole job there. There we go. So I'm left with just the one now. Let's see if this has an operation. I got toolpath. Let's see. All right, start simulation. Got to make sure I do not save anymore. I'm going to lose all those toolpaths I did back in the day. All right, come on. There we go, much better. So again, I don't have any holes in here to plunge through. It's just kind of wherever it can, but we'll run it a little slow. And I'm even going to turn my part, my stock, I can turn it transparent so we can actually see the difference in the two shapes as it cuts. And we still have our remove chips option on, so I can turn that off if we don't want it to automatically remove it, but I'll leave it on. And let me turn my stock back to show because it looks better. And then as soon as it finishes this cut, it should drop away. There we go. Now we're doing our skim pass around. And if we look at it from the bottom, you can see that taper on there. And it looks good. Overall, the sync lines lined up pretty good. I wasn't too worried about it with that part, though. So there it is. All right. Any questions that you guys might have, feel free to enter them in. Like I said, today's a little shorter than we normally do. I think I might make this the regular. From talking to a bunch of you guys, having 4 hours, both in the morning and 2 in the morning and 2 in the afternoon might be something we change. So